That's pretty cool. I'm doing that now, okay?
Hello guys, making a quick video, vlog almost, but today we're going to be doing something pretty cool. This is recorded with really bad sound on it. May have to do this again. This is being recorded on my XP camera, Fine Pix, Fujifilm, and it can go underwater and stuff. And you see this white thing here that Mick is holding? It is a underwater diving helmet that we have created out of a plastic shopping bag and duct tape. Now, I have just done a test of an underwater run, and I have walked from this middle of the pool down to where that vent is, completely breathing. This water goes out here, all the way on the bottom, and we counted 20 seconds. Out here, you stood out here for 20 seconds. Walking perfectly well. It was amazing. It is as good as anyone dreams it. I was actually breathing, talking to myself. I'm going to get out really quickly. I'm going to try and get you a footage of us walking on the bottom. Thank you, old me. Now back to new me. So basically, this is something that we did over the summer. And we decided that we needed to make a diving helmet because we got bored, and you know, it's us. So, we decided to make a diving helmet out of household items that we just found around the home, including some rocks in the garden. So, what we decided to do was make a basically just inflatable helmet that could fold down into a good compact, and it would also be form-fitting because we didn't really know how to make a rigid shape at that point. So all it is a plastic bag, like a bin bag, covered with overlaying like strips of duct tape, and that created a strong enough seal, or it was firm enough so that it wouldn't in fact pop under the immense pressures that it was being subjected to. And if you can hear that noise now, that is in fact bubbles just hitting the camera. It sounds like dying people, I know, but back to the bag. It also has it's a pretty thick plastic layering on the front that acted as a viewport. It was 4 layers thick, I think, just to make absolutely sure that it didn't leak, and everything was sealed from the inside. That's important because the way that the air would escape would be through, if it was attached to the outside, the pressure could easily force its way through to that seal, but if it was sealed on the inside, the pressure, if there was any air in there, it would leak out to the outside, but nothing would leak from the inside. So that's the reason we've done that. And you can see the viewport there with the multiple layers, possibly, if you can look hard enough. This is an interior view with Mick inside. He'll be talking you through this, but probably very quietly, and that's why I'm talking, because the audio is so bad. Yeah, so this is the first test, which was only about a second, 2 seconds. And the reason for this was we didn't discover how we would push ourselves down for more time, which was actually to use the other person as a weight on the top, which would push down at the shoulders, using as leverage to keep the person underwater. Now, our first tests were a little bit timid and lasted only about 5 seconds, but we soon discovered that there was much more air in there. So I performed longer and longer tests, just because I'm the smaller one, so I could be pushed down more easily than Mick, just because he's about 6 inches taller than me. So, another weird thing about this is there was actually a funny smell inside, and that's just because it's a duct tape filled bag with a seal underwater, so absolutely any gases in there would be trapped in there, and so all the smell would kind of build up. It was a little bit, it smelled kind of weird, it smelled like tape, so that's fine though, it was all worth it in the end. And you'll be able to hear just general noise. That is just that's just sound vibrating through the membrane of the inflatable helmet there, and all the sound, because when you're underwater, air does not transfer sound waves easily into water. So basically what you get is a very good acoustic chamber, and generally speaking, well, what that basically just means is all the sounds will start echoing inside of your helmet, and because it's not easy for them to escape into the water until they eventually just die out. So everything you hear in there sounds a little bit echoey, and it sounds like a little bit like this, because every sound wave that you produce is just bouncing around inside of there. So we tried to experiment with a 1-minute test, and we in fact succeeded. And we walked a fair distance around the pool, as Mick said in the beginning. However, problems arise, such as this clip is showing the problems then, just of the reflections, and other problems for staying under, such as ballast problems and whatnot, meant that the whole thing would tip. And that can be problematic because it starts to leak when it tips, because water gets in through the gaps. So we decided just to kind of do a sitting down and see how long we could stay for there. And that went surprisingly well, so we've got Robbie here, my little brother, doing the footage, because we required 2 people to actually operate this system. You can see the ballast, my birthmark there. That is in fact a birthmark, not a burn, not anything like that. So underwater, the helmet does have a pretty good form. It acts as a shield and just a general bubble of air around you. And it's actually really peaceful inside. Now, you can see me holding out 1 thumb, and that's our signal for everything's okay. Our signal, if we put 2 thumbs out, that means I can't get out, stop and get me out of here. Just as a life-saving device, you know, nothing big. But yeah, so we came up with our own code so that we wouldn't drown. And you can see no leaks. That I'm so proud of our first prototype, because it was absolutely perfectly airtight. And you don't understand, the pressures inside of that were immense. You'll see Mick actually slip here, and the whole thing goes terrifyingly shooting upwards in about 5 seconds. Yeah, that's terrifying, because your protective bubble is just diminished. Coming up to the end of the video now, and you'll see me at the bottom of the pool when we've anchored 50 pounds of iron to the bottom of this, in the form of weights, of course. But that is how buoyant this thing was. To get this thing to sink, we needed 50 pounds of iron. So the pressures on this whole thing, I'm very proud that we got it. Was it all attached by string as well? So the pressures on this thing was immense. So our engineering lasted us, but sadly we experimented too far. Put new windows in this thing, and you can see those cascading at the top, those like lines at the top are in fact, yes, leaks. So it was enough, it was fine, it could last us about 15 minutes before it fully deflated, and we would never be down that far. But coming to the end of the video, so I'm running out of time. Yeah, so anyway, this has just been one of the things we screwed around in during the summer. I hope you kind of enjoyed it, and hopefully it inspired you some ideas. Yeah, but don't experiment too far, as I say, keep it simple, or things like this will happen. You can see the 2 weights at the bottom there, and Mick's trying to get in, but it doesn't go to plan, and so we had to scrap the idea because the whole thing started to go downhill. I hope you enjoyed this video. My name is Michael Stahl, or Turtle King, and I will see you guys next time.